Hello. Thank you very much for giving me the opportunity to join you today. It's been a very interesting discussion so far, at least this last panel conversation. And let me start by saying that I am not going to talk about the implementation of storage systems. I'm going to talk around storage. Not about storage. Well, actually, maybe that's not quite true. I'll leave you to decide when I'm done. But I work in a product engineering organization at Oracle. I work in the systems unit. We're the folks that are responsible for doing the microprocessor design. And you had a session earlier today, I think, where you had 20 minutes of gory details. Or maybe that's not the right word. I guess it depends on how you feel about that. But you had lots of deep dive on the processor design. I think you heard a little bit about how we've optimized the new generation Spark processors for Oracle database. And I'll touch on some of that, but I'm actually going to talk a little more about why we're doing a lot of these things rather than trying to talk about what they are directly. And well, here, let me say this too. So it's late in the day, and I know that being informative is useful, but I think being interesting is more useful. So if you would rather that I danced or sang songs, I can do that, all right? But I cannot let you go to sleep, right? So, okay, so where are we now? Let me see if I can get this presentation up. So we have this big idea, there we go, at Oracle. It's this idea that you're gonna have, computing systems on the other end of network connections, and those systems will be far, far away in data centers potentially owned and operated by people who aren't you. And we're thinking about calling this cloud. I don't know if that name's going to stick, but it makes sense to me. All right. Too dry, huh? All right, so there are some benchmark numbers. There's a disclaimer here. I trust you can all read it. Yeah? Okay. So I'm covered now legally, right? Okay, and by the way, nothing that I say here today can be construed to be the truth, nor can it be used in any contract. So if you really like something that I'm going to show you a picture of, you'll have to talk to somebody else about the commercial details. So, Oracle, we have this database product, very successful product. The technological landscape that we are in today is pretty different from where we were when that technology was originally developed. In some ways, it's very fundamentally different. And part of that is because expectations around not only the implementation technologies, but the commercial models and the modes of deployment, of operation of that technology have changed dramatically. So, we went from a time when people were trying to decide whether they built their own relational database or licensed software from us to this modern era where it's all about cloud scale deployments and petabytes of data and applications that have global reach that are used by tens of millions of people, and just the scale, the pervasiveness of the technology, everything really has changed. Many of our customers today are very concerned about complexity. Complexity, by the way, is a problem you can never outrun because managing complexity is, I think, what most of us get paid to do, right? Yeah. So I'm not that old, but the very first system that I worked on, the first software I wrote was assembler for Timex Sinclair ZX81. Anybody here ever own a ZX81? See? I find that hard to believe, actually, but okay, I'll buy that. Couldn't afford one. Oh, yeah, well, I couldn't really either, but I don't know, somehow I got one. The complexity that we were confronted with at the time was pretty significant. And clearly, there's been a lot of technological development. We've developed a lot of things like 4GLs, and we have much, much faster machines. And yet, strangely enough, the work that I do today seems just as complex as the work that I was doing then. And what I realized some time ago is that Our job is to stay ahead of complexity. We're trying to outrun an infinitely fast predator, and we just stay one step ahead. That's the best we can ever hope for. So we are dealing with complexity today. We'll always be dealing with complexity. The challenge is knowing just how far you can push things. There are a few things that have remained constant. Complexity is expensive, always has been, always will be, and complexity is not going away. Security is always important. It's always been important. It will become even more important in the future. That's likely never going to reach a limit either. Everyone is trying to optimize the investment of resources at an economic level. Just forget about commerce for the moment. By the way, I'm going to try and stay away from commerce. I'm going to talk about cost, but I mean raw kind of economic cost, right? Investment of effort, investment of time. And then agility, of course, is the ability to roll back things that we've done, the ability to make mistakes that aren't crippling for our various initiatives. So we need the ability to change our minds and sort out new things without having to write off all of our previous investments. These are all true, always have been and are today still true. So I'm going to talk a little bit about this large landscape now. I'll talk about cloud. So how many of you, offhand, you guys know the speed of light if you measure it in miles per hour, a second? Yeah, I think 186,000 miles per second. Like infinitely fast, right? Well, I suspect you all being educated engineering people would know that that's not true, in fact. It's only about 100 kilometers per millisecond round trip through silica. Which is remarkably slow. So here we have we're on the cusp of something that is transformational, right? We've got these large, these expansive, generally pretty reliable networks, and there are all these enterprises out there that are discovering the joys of connectivity at a scale with a level of ubiquitousness that we've never achieved before, right? And so we have this big conversation about cloud, and ultimately that's what cloud really comes from, right? Is this idea that I now have new tools that let me optimize locality. And locality as a pattern, by the way, is a really important pattern. I'm going to actually, I'll be talking about stuff that's peripheral to locality here in a bunch of places. But it's an important thing to keep in mind is one of the central problems with cloud is moving large amounts of data over slightly unreliable, in some cases, and relatively slow networks. And again, even the best that we have are limited by the speed of light. So if you're thinking about transactional systems, for example, it's good to keep in mind that the round-trip latency best case, with no amplifiers in the path between, say, the east coast of the US and northwestern Europe, is about 60 milliseconds. Okay, so for those of you that are interested in transactional systems, then that's an insurmountable barrier. And it raises the question then of, well, how do we do these large-scale cloud deployments where, in fact, the size of the world is a significant issue, and it has a big effect on where it is I actually put data, and if I need reliability, if I need something like synchronous replication. All of a sudden, I have this really interesting challenge, right? On the one hand, cloud is supposed to liberate me as a user from the location of the systems that are actually managing the data. On the other hand, that doesn't actually work because the speed of light's not enough. So anyway, Oracle has this idea that, in fact, our customers are going to look for a number of solutions to the problem of complexity. So the one that we've focused on for the last few years is taking away the problem of assembling and testing and supporting large-scale mission-critical systems. Right? Getting a very high-performance storage infrastructure is not impossible. A room full of clever people with some open-source software and some cheap hardware can, given enough time and enough motivation, develop a very large-scale, very highly reliable, high-performance storage system. The trick is that it's very difficult to support, and it's very difficult to hand that technology off to any other team. To do that, you need to productize, and you need to wrap this thing in standards for testing and the training material, and you need to create the ability to not only deploy that software and hardware, but you need to actually integrate it into the organizations that are going to be consuming and depending on it. And our feeling is that many companies probably don't want to do that anymore. and that they're a lot better off if Oracle takes on some of that heavy lifting, because those kinds of processes, that kind of work, that's what we do. That's what we exist for. So we've been focusing on integrated systems, engineered systems, Exadata as a product some of you might have heard about. That's probably the flagship storage system for Oracle database. Best in the world, built with Oracle database. In fact, it's tightly coupled with the Oracle database architecture. So it's a great example of how Oracle is able to do really, really hard engineering, but to do it in a way that makes it available to companies with relatively low cost and with very consistent results. Now, cloud comes along, and now we have customers saying, well, Oracle's taken on a bunch of the hard work of putting the pieces together to give me very high performance storage, but now I don't want to buy it and own it and operate it. Now I want to just rent it. I want someone else to house it and power it and clean it and cool it and tune it up and maintain it. I don't want to touch it. I just want my SQL to magically fly over the ether, and I'm going to get my results back. And we can do that too. But again, we're constrained by the speed of light, and we're constrained by some other things too, which are security and data sovereignty. And I'm distinguishing between those because data sovereignty is often thought of as being a byproduct of security concerns, and it may or may not be. Right? So you have to think of it as a different thing. But the bottom line is that for many enterprises where there is any kind of a legal obligation between the users of the data and the people that are managing it, the state has a role in deciding where that data can be. So we have data sovereignty as one issue, and then we have security as another. And there are many organizations that ultimately rely on, as the last bastion of security, security through obscurity. And so they won't even ask you whether or not you can comply with their standards, because disclosing their standards represents a security vulnerability. It's a vector of attack. So they say, no, for security reasons, I cannot let you touch my data. So we have these engineered systems. They're very useful. We have customers that want cloud. That's fantastic. We are now offering a middle path for our customers, which is the ability to have effectively, technically, an Oracle cloud, but deployed at a locale of their choosing. They consume it as if it was a cloud service, as a subscription, but they get around the data sovereignty and the speed of light problems by being able to put the data, the storage, physically where they need it to be. And we're one of the few cloud providers that can do that. Microsoft Azure has done a good job of working with hardware vendors, for example, HP and Dell as examples there, to provide standardized hardware configurations for Azure so it can logically be deployed on premises. But in Oracle's case, it truly is 100% Oracle supported, developed, maintained infrastructure. So, and I guess aside from Microsoft, frankly, there really isn't anybody else. So if you aren't in the business of rolling your own, as they say, then we have a fairly unique offering. But I want to talk a little bit about data protection. Security is a big deal for us. And for anybody that's, anybody here have issues related to the, what's the encryption attack that happened yesterday? What's it called again? WannaCry? WannaCry, WannaCrypt? Anybody have any personal experience with that? Oh yeah, well, yeah. Oh, I don't have any XP running anymore, but yeah, so security is one of those things where major organizations have a challenge. They don't like to talk about their vulnerabilities, right? They don't like to ask you questions about what you've done, because asking you the question discloses that there's something that you may or may not have done and that they don't know about it. So people don't ask you about security, and they don't tell you after they've been breached, because nobody wants to disclose that they had poor security. But let me tell you this, if you're the person who made the decision to deploy a system that is not secure, after you've been compromised, you will be held in contempt for your failure. You're never going to get a warning that you need to do it. You're only going to get told that you should have and didn't. And so we're finding many of our customers are coming to us quietly and saying, I need your help. I need you to help me. This is a career-limiting problem for me. I need to do things that aren't going to increase cost, that are going to improve security, because I just saw the person next to me get demoted. And no one ever really explained why, but we all know why. So we're very concerned about baking security into our products, and in particular into the data protection lifecycle. So when we talk about these engineered systems, we don't just optimize the performance and scalability of the systems. One of the things that we spend a lot of time on is security. And think about this. In a cloud world where capital efficiency is only possible if you have a truly software-defined infrastructure, right? Where you can no longer rely on perimeter security to protect your data and your systems. The underpinning of all strong security is pervasive encryption, right? So you heard earlier today about the Spark chip and what we're doing with crypto acceleration. Well, to give you a commercial context, think about this, that broadly speaking, your vulnerable data is going to exist in 3 places. It's going to exist on some kind of a media, and you can encrypt it there, so that's awesome. It's going to exist in transit. It's going to be sitting somewhere on the network, and you can encrypt it there too. Fantastic. The data is going to be in memory somewhere. Well, that's been a bit of a problem because you can't encrypt it, at least not with any technology we're aware of. And that's why we've concentrated on things like silicon secured memory in the processor, right? So that we can protect all of that data that's now sitting in memory in those systems. But let me start with crypto, or actually silicon secured memory. So I think you had the briefing on this earlier today, so I'm not going to go into it in a lot of detail. Did everybody here catch that, by the way? The session earlier where silicon secured memory was discussed? Yeah? It's really interesting technology. It's a long conversation, potentially. So I'm just going to assume that you all have a little bit of a background there. And now I'll jump to encryption. So again, if you take the viewpoint that we have today from an architectural perspective, for cloud to work, for us to get the capital efficiency that we need from large-scale deployments, we need to encrypt everything. And that's why we have added very, very powerful encryption coprocessors, acceleration, to our processors. The advantage for us is that it improves, or at least it doesn't affect application performance, but it dramatically increases security in a very, very fundamental way across the stack. And I'll give you an example of what I mean in a large-scale deployment, cloud deployment, for example. You know, historically, we have used perimeter security to isolate customer environments. So imagine that, and many of you know this pretty well, I think. Imagine that you've got 10 tenants sharing a data center. Well, you give them all cages, that's fine, right? So they've got servers, the servers are in cages, the cages have locks on the door, that's fantastic. All of those cages are piped directly back to your core network because they shouldn't touch each other, because that represents a security limitation. Now, if you want to deploy a cloud environment where you can flexibly allocate resources, how do you do that? Well, you have to integrate them all via some kind of a networking layer that allows you to dynamically create secure environments and control which resources are exposed to each environment. That's been very challenging to do prior to fully deployed SDN. And so many customers have this challenge where, in order to satisfy security requirements for their tenants, they're forced to arbitrarily assign very large amounts of storage and compute resources, and in a very inflexible way. They can't dynamically grab those resources and put them elsewhere, which means that their capital costs are significantly increased over what they ought to be. Now, let's take a VMware environment, for example. Let's suppose that I'm a tenant in your cloud and you're using VMware or some other comparable hypervisor, type 1 hypervisor technology. If I want to be able to service the environment and I want the ability to do things like live migrate virtual machines, the only way that I can do that in a secure way, since I'm not encrypting those virtual machines or encrypting that data as I move it, the only way to do it in a secure way is to rely on perimeter security. If I have an inflexible network layer, then I have this arbitrary boundary around this giant pool of resources, and a whole bunch of it goes underutilized. If you can do something like fully encrypt all of that data as you move those virtual machine images from host to host, then you have the opportunity to no longer be dependent on strong perimeter security implemented in the SDN layer in the infrastructure. Now you have strong security that is totally decoupled from your networking layer because you can encrypt and move virtual machines on the fly at wire speed. And that's one of the advantages that comes from Oracle developing its own processors. It effectively gives us an enormous architectural advantage in the design of our cloud infrastructure. This is something that also shows up, of course, in our engineered systems. Now, security, runtime, I would call runtime security, right? Things like encryption and memory protection is very important. For many of our customers, being secure isn't enough. They need to be compliant. And so another important thing that we're dealing with here is how do we automate compliance? First of all, how do we build systems that are guaranteed to be compliant? And then how do we automate the compliance? And there's quite a lot of work involved in doing that. And to be honest, one of the ways that we have addressed security and compliance is through limiting the scope of the effort. So for example, for applications that require very high levels of security, like ERP systems or core banking or systems used by the military defense department, for example, we create essentially data centers that are self-contained, where the application tier, the database tier, the networking, it's all inside the system. And then we design compliance tools, security tools that go with it. So we deliver not only the runtime security advantages like the silicon secured memory and the crypto acceleration, we also deliver systems that have been pre-tested to be compliant with all the relevant standards. And then we deliver automated security tools that will let customers create security environments without having to be security experts or know the implementation details of the systems. And then finally, we deliver automated compliance reporting. Now, we're in the process right now of trying to figure out how to scale this up, because to solve the security problem required that we get that we take a very controlled view of what it is we're trying to secure, right? We made the problem smaller in order to solve it. Okay, now we're trying to figure out how we can solve the same problem from the customer's perspective, but at cloud scale. Okay, this is one of the areas where Oracle is investing an enormous amount of money, and some of the most brilliant people I've ever worked with right now are working on this particular problem. But this is an example of a screenshot of something we call Security and Compliance Virtual Assistant. This is something that we're in the process of trying to scale up to our cloud right now. We can do this today with systems like the supercluster and this mini cluster system, which are small-scale integrated compute storage converged infrastructure systems. But this technology, as I said, is something that we're trying to bring to cloud scale. And essentially what you see here in this screenshot, I guess it's a bit far away for most of you back there, but if you could read it, what you would see is essentially a simple screen that presents the interface for the creation of VMs for database or applications. And it provides a simple drop-down menu that offers PCI DSS compliance, CIS equivalent, or DISA-STIG, which is the Defense Information Systems Agency Secure Technical Implementation Guide scored standard, that's the most complete set of security standards that I'm aware of, is the DISA-STIG. And that means that a DBA or a developer that doesn't really know anything about the infrastructure can simply choose the right option and hit go and create an environment that's fully secure. They can see the score for the DISA-STIG. If you know something about DISA-STIG, it actually has a scoring mechanism built into it. And then in addition to creating the secure environment, we have the audit policies, things like key management and scheduling automated compliance reports, and this is an example of doing that here. So the goal is, again, to take away that not only the security complexity, but the compliance complexity as well, and generating automatic reports. So now very quickly, I'm going to talk about performance. Again, I'm glad you've seen a lot of this material already, so I don't have to talk too much about the chip. But the acceleration that we have built into the processor, that we've engineered into both Oracle Database, frankly, and this Spark processor, is quite dramatic for in-memory database. And not just Oracle Database. In fact, that technology is suitable for other workloads too, and I think you'll be hearing some third parties talking about that very soon. Apache Spark, for example, or Quartet file system, and other technologies, Java Streams, optimization. An Oracle Database 12.2, of course, has some new features. There's a hand-in-hand code development of the processor and the database, so it's very iterative. They both continue to work together to get better from generation to generation. And we're doing the same thing for Java. So filling a data center with hardware is very expensive, very expensive. And here's the thing is, if we think about the kinds of workloads and the kinds of customer use cases that we're dealing with today, right? It's the tip of the iceberg. So I remember a time when only about 10% of the population had access to the internet, and that was dial-up. They were only on it when they were explicitly on it. They had to do it. It was a thing you did. I'm going to go home in AOL. Now, 20 years later, connectivity is pervasive. We went from having a single device that could access the internet, that could access any kind of a data service, and now most of us walk around with 3. Typically a watch and a phone and a laptop or something in your bag, and you've got one in your car, and you've got a tablet, and this is just the very, very beginning. So we're in the process now of trying to figure out how we can accommodate the kind of scale that is already commonplace today. But the truth is that this technology is going to drive us to a whole new place. The scale of the systems that we're going to be deploying in 10 years is going to be 2 orders of magnitude greater than what we're trying to deal with today. So we're very concerned with things like power consumption, square footage, which is why we continue to design our own processors, because when you're deploying 2 or 3 million cores, you need to do everything you can to optimize your use of space and power and so forth. So we're very concerned about performance, and in particular for in-memory workloads. So again, securing the data, making sure that the data can be secure no matter how it's deployed, whether it's in our cloud or on the customer's premises or wherever. Making sure that we are optimizing in-memory query processing so that we can have real-time performance from applications for doing things like sentiment analysis or fraud detection or user interaction for services that may be, for example, monitoring social media feeds, looking for information about what a particular user is doing or thinking at a particular moment, which would create potentially a commercial opportunity or which would give us an opportunity to do something to help them, right? These are all new challenges. So it's this combination of the performance, the scale, the security. And from Oracle's perspective, engineering processors is a small price to pay to obtain a very significant competitive advantage. It's one of the reasons we're not the only major cloud provider that's doing this, by the way. And then, of course, in the current generation of the Oracle Cloud, we are in the process of rolling out an end-to-end software-defined network architecture, something we call bare metal, and that's, if you're interested in reading about that, there's a lot of material online. And bare metal is really all about having a massive scale flat network topology that allows us to dynamically carve paths from any network-connected endpoint in that cloud to any other network-connected endpoint that is secure, and set those up in a matter of seconds and tear them down in a matter of seconds. This is an important part of getting capital efficiency and preserving application performance, and also ultimately the performance of the large-scale shared storage that is the underpinning of the Oracle Cloud. Now that was a bit of a kind of wander through a whole bunch of sort of related topics. These are all things that I find just really fascinating. But anyway, locality for me is a pattern that is super important for us today, and it's going to get more and more important in the future. And then the other thing that I really enjoy is just thinking about how the speed of light's not really that fast. That was really an eye-opener for me, frankly, thinking about how do you do large-scale distributed systems, and how do you get around the constraints of the speed of light through silicon. So anyway, thank you very much. And if there's anything that I might have talked about today that's interesting enough to warrant a follow-up, please talk to this guy right here. Thanks. Oh yeah, any questions? Are you all building storage? Is that your primary interest, by the way? How many of you are really concerned with the challenges of building storage systems? Hands? Yeah? And how many of you would be willing to step away from that complexity if a vendor could just kind of do it for you? Yeah? See, but not everybody put their hand up. It's all different communities. I think that's very fascinating, by the way. Because I like building stuff too, right? It was a great hobby. But it's really interesting to see how many folks just enjoy it. Do you enjoy it? Is it you do it because you just like the problems? It's like playing a game. You know, you're looking for a technical challenge and you're going to try and find a solution, and it feels good because you can measure the result, right? You can test it. You can test yourself. You can actually give yourself a score. How long did it take me and how elegant is my code, right? I like that too. And I got to say, I'm trying to sell many, many people, I'm trying to sell them an Oracle solution because it makes business sense. But the reality is a lot of us just aren't, it's not why we do these things, right? And I'm cool with that, by the way. So enjoy your technology, right? I wouldn't be here if I didn't love it. Thanks.